Hello, Priti. How are you? You can unmute and speak. Okay, you are in library right now. So this time will be a good point to start the session. Because it will continue for 2 hours straight. Okay, 7:30. So 7:30 will be quite late because it will go straight for 2 or 2.5 hours. It will move to 9:30. And we have one more session with respect to mentor case. So it will again take 1 more hour. So 9:30 to 10:30 and 11 it will go. So shall we start now? I'll try and I'll sum up the session early today. Okay. Okay. So let's start the session here. We have actually, I want to ask you one thing. Have you went through the session plan that I have given? It is of 100 days complete. And in every session, we will be covering certain topics from geography optional syllabus. Okay, we'll be taking syllabus. We'll be also looking at certain PYQs and we'll be moving ahead then. And for the mentor case, June 2025, whatever the cases I have able to put up, I have taken cases from various sources, down to earth. Then there is a magazine that is called as Geography and You, then National Geographic, very relevant cases from physical geography. Then we have Progress in Physical Geography. It is also magazine. Then Earth, it is a magazine of Government of India, which is providing specific cases. Then Science, okay, then a Science Journal. There are certain important cases. Then Earth Interaction, very important journal, which is providing various important cases for us. Journal of Geophysical Research, okay, that is Earth surface. So whatever the changes over the Earth's surface is taking place, we are looking at those case studies. Then Progress in Physical Geography, another important journal which is providing the Earth systems, hydrological systems, and aerosol cloud systems. Then Annals of uh, Annals of Geography. This is also one of the important journal. Then Economic Geography. It is one of the specific journal for economic geography. Then we have Geographical Review, okay, where there is certain nuclear risk and the urban geographies. Then Small Ships Driving Big Challenges. Then Geographical Environmental Change. It is also one of the journal. Then we have Climate Change as one of the new journal where we can look at certain cases. Environmental Management, then International Science and Technology. Here also we got certain cases from NASA Earth Science Data. Then we have various cases from PIBs also, like Envistats India 2025. Then we have Coastal Mission Budget and its management. Then we have the Hindu also. Here we can have certain cases here. Then we can see the climate policy initiative by Government of India. Then we can see certain cases are also taken directly from the websites of UN. Okay, then UNEP, UNDP, UNCCT. Okay, so these are also important cases which will be covered in the 30 days. In next 30 days, more than 100 cases have been identified, and this June cases, it will be covered up by mid of July. Okay, so this is also another important class which will help you to run up with all the important cases which are in news, not only the sources which we are regularly reading, but also from the sources which are non-traditional, okay, which are unconventional in nature. Okay, Priti, so shall we start the session? Okay, so let's start. So here, the today's topic, what we have, the topic number one, it is the origin and evolution of Earth's crust. And the next topic is the interior of Earth. I think you have attended a few sessions which were covered up earlier in the last classes in the mains answer writing. Have you seen those videos? Okay. So here we'll be taking different questions which are quite relevant and where direct questions can be asked in examination. So first question which we'll be looking here, this is, how do the homogeneous and heterogeneous model? Okay, homogeneous and heterogeneous model. Explain the origin and evolution of Earth's crust. This is a question of 15 marks. Okay, this question is taken directly. Okay, you have to write it in 200 words. Okay, take 7 minutes and write an answer. Share answer by uploading it here. Then we'll look at the answer and we will discuss in the live format. Okay, Priti, let's start. Hello Yogi, how are you? You can unmute and speak. Are you preparing for a geography optional and appearing for Mains 2026 exam? You can also type message if you are somewhere outside and not able to speak. Hello Yogi. So have you completed your foundation or you are pursuing it or you are self-preparing? Okay, you have finished paper one. Okay, so rest of the talk we will have after this session. So you might have completed geomorphology. So under the geomorphology, we have one of the important topic, that is the origin and evolution of Earth's crust. Now the origin and evolution of Earth's crust, it is seen from the general perspective and it is also seen from the perspective of geography. So here first question we have, that how do the homogeneous and heterogeneous model explain the origin and evolution of Earth's crust? This is a 15 mark question. Okay, you can take 7 minutes and you can share your answer. You can write an answer in a paper and you can share it here and we'll discuss over it. Okay. Okay, not an issue. We will be helping you for preparing paper two also, because it is also quite comprehensive and it requires models, theories, laws, and perspective from paper one, which will be helping you to complete the course within your time. You will be having time for revision also, because these classes are scheduled for 3 lectures in a week and we will be covering 4 to 5 questions daily. Okay, and there are more than 100 lectures where you will be able to very simply self prepare and you can also write answers. You will be having a complete 500 plus answers which you have written, and the very developed perspective with respect to models, theories, laws, and case studies, which will help you to integrate everything in geography optional. Okay, so Yogesh, try to write the answer. This is the question, and then we will discuss it. Okay, Yogesh? So this is the question. Okay, so Preeti has completed the answer and she has shared the pic. Let's look at it. Okay, so I'll be reading the answer. How do homogeneous and heterogeneous model explain the origin and evolution of Earth's crust? So one of the example, very good example is given by Priti about the Australian National University's geoscientific research. Earth's crust began forming about 4.4 billion years ago. Excellent, as revealed by iron crystals found in Western Australia. Excellent. The origin and evolution of Earth have been explained mainly by two theories, okay, homogeneous and heterogeneous model. Okay, Priti, you can also add up here the homogeneous model, heterogeneous model, catastrophic model, and non-catastrophic model also. So non-catastrophic model came after the quantitative revolution, which consisted of the systems analysis. Okay, so you can just give a brief about this part in a short form. Then talking about homogeneous model presented by early geologists like Jeffrey and Darwin, very good, provided that the Earth was initially a homogeneous, uniform composition, molten mass, and over time, differentiation occurred as heavier material occurred, sink towards the center, and lighter materials floated upward. Okay, so this is a good point here. Then next we have the process during accretion, heavy materials. Okay, this is, I think, yeah, forming the layers, the core, mantle, and the crust. Process, the early Earth was uniformly composed of silicates and metals. Gravitational differentiation occurred. Okay. Then iron and nickel moved towards core. Okay. Silicates rose from the crust. Okay, very good. The crust formed gradually on Earth and cooled solidified externally. Great. Now, heterogeneous model propounded by researchers like Wichert. He provided that the Earth formed already from differentiated cosmic materials, metallic and silicates components, okay, accumulating in layers. Now, process during accretion, heavy metals, metallic bodies were attracted first, forming the core, later the lighter silicates. Okay, the Earth was layered right from its formation so that the crust evolved as the outer silicate material cooled and solidified. Okay, both models attempted to explain how the Earth's crust and internal structure of the Earth evolved. Modern understanding, supported by planetary formation theories, leans towards the heterogeneous model. However, aspects of internal differentiation, homogeneous model also played a role in crust in later evolution. Okay, so Priti has written one answer. The answer is quite good, but we need to have a basic understanding like what happened during the homogeneous model and what happened during the heterogeneous model. So here we need to add up one important theory, that is the nebular hypothesis theory, which is missed here. And this theory, it explains that how the Earth's homogeneous structure or heterogeneous structure was found. Okay, so this complete aspect of nebular hypothesis theory, it is being missed here. Okay, so we will be writing answer, we'll be understanding how to incorporate it. Okay, Priti? Yogesh, have you completed? You still need some time? Okay, complete it, then we'll discuss. Are you guys comfortable in English and Hindi? Okay, Yogesh has sent the answer. Yogesh, you can also send it in the group. Not an issue. Okay. Yogesh, you are also comfortable in English and Hindi? Okay, not comfortable in Hindi. Okay. English is comfortable. I am from Tamil Nadu. That's great. From where are you from Tamil Nadu? I have a lot of students who are from Tamil Nadu. Coimbatore. That's great, yeah. Coimbatore is a great city. Now, let's look at your answer first. Now, since the Earth has been developed through various processes and formation till today, it has homogeneous and heterogeneous evolutions where the crust are evolving and subducting every day. Okay, so homogeneous evolution, first accretion, the two nebular celestial bodies secreted by the formation and forms the molten magma in which the heavier since and lighter front solidified in the crust, then differentiation. Okay, so this is for homogeneous part. Then for heterogeneous, contemporary accretion and differentiation. Earth experienced large scale of melting and developed magma ocean. Magnesium perovskite started in crystallize at the base and magma ocean. Formation of magnesium perovskite resulted in self-oxidation. Okay, so a reaction is given here. Formation of metal from the process which led to heavier metals core and lighter metal crust and mantle. The continent which floats on the crust, which has been explained by the Alfred Wegener. Okay, the mantle plumps and subduction takes place where the continent formation tends to evolve. Okay, so I can see the answers have been provided here. Yogesh, you can chat at the main chat part here. Okay, you can chat here also. So that will be easy for us to look at the chat and answer. So it is not a thing. We are here to understand and see what is happening when we know that where we are, who we are. Okay. So when we accept it, so it will help us to improve at that point. So don't shy. Don't feel like if anyone will see my answer, then what will happen? No one is judging you. Okay. Now, from the answers which we have seen here, as Priti has attended one of my sessions earlier, see, she has included most of the points which are important. Now, let's discuss this answer. So, as Priti has already written in the part of introduction, that there has been a research taken place at Western Australia, where the rocks have been carbon dated. Here we'll be seeing that there was a specific dating of iron and zircon crystals. And this evidenced the formation of Earth almost around 4.4 billion years ago. Okay, so this is one part which we can understand, that we need to have certain evidence. This is very much important for the optional perspective, where you need to specify that what is evidencing that the earth has formed almost around 4.4 billion years ago. But here we'll be seeing that to understand this process, there are two important we can say processes are here. One is heterogeneous model, and number two is homogeneous model. Okay, so these two models, they explain that how the formation of earth has taken place. Besides this two model, what I will be specifying here, that apart from this we also have catastrophic model, and number four, non-catastrophic model. Which helps us in understanding the formation of the Earth's crust. Now, for all the models, we'll be seeing that the initial condition is taken from nebular hypothesis. Okay, and this nebular hypothesis, it was presented by Kant and Laplace. Okay, so these were the two theorists or two scientists who propounded this nebular hypothesis, which actually said that the formation of the protoplanets occurred because of the cohesion of planetesimals. Okay, so these are planetesimals, and this is a protoplanet where we see that thousands and millions of the particles, they have coalesced together. Okay, they underwent the process of cohesion, resulting into the formation of planet. Okay, so Earth is one of the protoplanet, almost around 4.6 billion years ago, which was formed here. Okay, now after this, what we'll be seeing that here comes that question. Here comes a question that how the Earth's crust have formed. The first theory which was provided here, it said that the Earth's interior, okay, it was homogeneous. While the other theory said that the Earth's interior, it was heterogeneous. Homogeneous meaning there was a uniform presence of materials from crust to core. While the heterogeneous model said that while the Earth formed, it pre it had pre-existence of differentiated layers. If we look at this diagram, here we'll be seeing that the Earth's composition was uniform. While here we'll be seeing that there was a layered structure of earth. This is crust, this is mantle, this is outer core, and this is inner core. So there was a dichotomy and dualism between the formation of the earth, okay, or we can say the earth's crust. So later on what we'll be seeing that under the homogeneous part, under the homogeneous condition, here they said that there was a density differentiation due to which the lighter material moved towards crust. For example, SiO2, oxygen, hydrogen, etc. Also magnesium to a certain extent. While the denser material, it moves towards core. For example, iron, nickel, cobalt, etc. Okay. While we'll be seeing that in the part of heterogeneous model. So heterogeneous model already says that there is the density was already differentiated and the layered structure was already formed. So here we'll be seeing that there are certain components or there are certain theorists who have propounded this part here. So for the homogeneous model, we will be seeing that the theorists who are associated with, that is Arthur Holmes, who has also given the convection current theory, along with him Goldschmidt. So they have propounded this homogeneous model. While we look at the heterogeneous model, it was provided by Hazen and Clayton. So they have provided this heterogeneous model here. So what we are able to understand from this homogeneous model and heterogeneous model, that when density differentiation occurred after this, okay, after the process of density differentiation, there was formation, or we can say there was cooling of Earth's crust, which resulted into the formation of first crust, that was the oceanic crust. Okay. While when we see to the part of the heterogeneous model, here the different density differentiation has already occurred. So the outer cooling or the outer layer or crust, it cooled and it resulted into the formation of Earth's crust, that was first oceanic crust. Okay, then they propounded further that there was localized melting. Okay, both of them propounded there was localized melting resulting into the formation of the continental nuclei. This continental nuclei, they came together and resulted into the formation of cratons. These cratons further they came together, they combined to form continents. Okay, so in this way we see that there was formation of continents here, okay, or the continental nuclei. But this part, it was not well explained. It was not well explained either by homogeneous model or heterogeneous model. But later on, with the development of catastrophic and non-catastrophic models, we were able to understand the origin and evolution of Earth's crust. Okay, so in the part of the conclusion, you can also write here that certain modern techniques like remote sensing, then GIS, spatial analysis, then quantitative geochemical modeling, etc., helps us to understand the origin and evolution of Earth's crust. Okay, so in these three phases, we are able to understand that what is happened here, what is the basic introduction part, then what are the various models apart from heterogeneous and homogeneous models, then what was the initial condition which is needed to be provided here, that was the nebular hypothesis with respect to the formation of planets, planetesimals and protoplanets, then how there was development of dichotomy and dualism in the previous part. Okay, how the interior was Earth, it was different in homogeneous and heterogeneous condition. Then how these two theories they differed here, what were the different theorists who propounded these particular models, and how there was formation of the first crust. But we also need to specify here the formation of the continental crust also. Okay, so continental crust is also needed to be specified, which is not exactly answered. Okay, which is not exactly answered here by these two models. So we need to provide a criticism of the model. This is basically a criticism. Okay, so criticism has to be provided, and how these other two models, it helps us to overcome this particular criticism and what we can achieve in the contemporary part with respect to the technological development. Okay, so this is the first answer which we can see is important from the perspective of. Okay, not an issue, Yogesh. So are you able to understand that how we need to take an approach for this particular answer? Priti, Yogesh, fine. Priti, okay. So this was the first question which we can see, that is that can be seen from the perspective of origin and evolution of Earth crust. Now, next, both of you have read this, all the parts: heterogeneous model, homogeneous model, catastrophic model, non-catastrophic model. You can answer in yes or no. Okay, Yogesh has read that. Okay, I assume Priti, you might have also read this part because we have covered this in the one of the sessions. So looking at this part, we'll be moving to the next question. Question number 2. So here the question is, how non-catastrophic model overcomes uh, overcomes the limitations of catastrophic model in explaining the origin and evolution of Earth's crust. Now, this question is also for 15 marks. Okay. You guys have understood the question. Now, take 7 minutes, try to write this answer, then we'll discuss it. Okay. Yeah, you can use the previous fact here also. It's not an issue. Yeah, question is here. How non-catastrophic model overcomes the limitations of catastrophic model in explaining the origin and evolution of Earth's crust? This is a 15 marker question. Okay, so Yogesh has sent the answer. Okay, so Yogesh has given answer. Let me look at the answer of Priti. Okay, violent events. Great. Rapid crustal solidification. Okay. No geological evidence of global catastrophic crustal formation. Okay. Radiometric dating showing crust evolved over billions of years. Okay. Internal processes like mantle, convection, magnetism. Okay. Layered structure or geochemical diversity of crust. Very good. Non-catastrophic model. Uniform processes and geological time period. Nebular hypothesis. Magnetic differentiation. Condensation of solar nebula. Accretion of particles, gravitational heating, partial melting, differentiation, gradual process into core mantle. Cyclic segregation, okay, uniformitarianism, slow geological processes. Okay, now what I can see in the answer of uh, Yogesh, that he has written an answer, but answer is catastrophic model is explained, limitation is explained, and then we are moving towards the non-catastrophic model here. Okay, then what are the postulates, supporting evidences, and then conclusion. While Priti has written a very good introduction here, okay, introduction is good, catastrophic, non-catastrophic explanation is good, starting from nebular hypothesis is good, but it is considered in, it is taken in both the catastrophic and non-catastrophic simultaneously. But what one thing I'm trying to find here, that what actually non-catastrophic model is doing better to overcome the limitations. For example, the limitation of catastrophic model is no geological evidence of global catastrophic crustal formation. Okay, radiometric dating shows crust formed over billions of years. Then how the crust of the earth is evolving, this is also not specified here. Okay, then the role of plate tectonics, as we can see here, the mechanism that addresses catastrophic model weakness, uh, the differentiation process, this is the initial part. Then magmatic separation, it is also initial part. Uniformitarianism, this is needed to be explained in detail. Okay, the uniformitarianism, that what is happening here, let's understand with this with the answer writing. The catastrophic model and non-catastrophic model tries to explain the origin and evolution of Earth's crust following the nebular hypothesis. Now, under this, what we'll be saying that under this catastrophic and non-catastrophic part, both have assumed that there was a process of homogeneous accretion has taken place, resulting into the formation of homogeneous Earth. Okay, so here we'll be seeing that the Earth structure, it is homogeneous almost 4.6 billion years ago. Now, both of the models, they agree to this particular part here. Now, after this, what happens? Number one, catastrophic model. Let's understand first with the catastrophic model part here. So what catastrophic model says here, that at the initial times, this is the surface of Earth. So here what is happening? There is an impact by the meteorite is also taking place. And there were violent bombardments are taking place due to the meteorites. Okay, this is resulting into the bombardments, which is violent in nature. So because of this, what is happening? Consider this as the surface of Earth. Okay, so meteorite, it is impacting in this particular region. So what will happen? Because of the impact, there will be tremendous heat. there will be tremendous heat, it will be released, and because of this condition, there will be vaporization of material from the surface of Earth. Now, because of this condition, what will be saying that there will be certain isostatic adjustment will take place, and here we have the molten magma. Now, because before this, I want to also explain that the first cooling, the first cooling of Earth's outer layer, this has resulted into the formation of oceanic crust. Okay, oceanic crust, it is majorly basaltic in nature. Okay, now coming back to this part here, number one, there was meteorite impact. Number two, uh, there was vaporization of material. And here we'll be seeing that from the interior part of the earth, the magma came out, and there was emplacement of magma has occurred here. This magma came out from the interior of earth. There was emplacement of magma. Okay, and this resulted into the formation of a continental nuclei. So this was the first step. This was the first step where we saw the formation of continental nuclei. And this process used to take place for millions of years, resulting into the formation of continental nuclei at the various positions over the Earth's surface. Now, this here we can understand from this part that how there was formation of the formation of the continental part has taken place, because we know that the continental crust and the oceanic crust, they have different densities and they have different composition also. Okay, density and composition, it varied for the continental crust and the oceanic crust. So here we'll be seeing that the continental crust, it had the density of almost 3 grams per centimeter cube, while the oceanic crust, it has 3.25 grams per centimeter cube. Okay, I am just making a correction here. This is 2.7 grams. Continental crust is 2.7 grams and oceanic crust is 3 grams per centimeter cube. Composition, it is basaltic in nature. Sorry, oceanic crust is basaltic in nature. While the continental crust, it is mainly granite or gneiss. Okay, it is majorly granite or gneiss in nature. Now, next thing what we'll be seeing here, that is the criticism, which Priti has very well explained here. Now, under the criticism, what is happening here, that because of the collision of meteorites over the Earth's surface, it is resulting into the formation of continental nuclei. Okay, and this is further resulting into the formation of cratons. This is also explained here. But what is it is specifying here that during the Archean era, the continental nuclei which is produced, it is because of the mantle lumps coming from the Earth's core and not because of bombardments. Bombardments of meteorites. Okay, so this was the first part here. Second thing here will be seeing that the moon's surface was studied. Okay, the moon's surface was studied here, and it was seen that if Earth would had same kind of conditions of the continental nuclei and the oceanic crust, but moon had a different condition. It did not had the magma emplacement. As we can see that the origin for Earth and moon, it is same. So Earth and moon had a different kind of conditions here. So because of these issues, because of these two particular issues, we'll be seeing that there was rejection of catastrophic model and there was proposal of non-catastrophic model. Now, when we move to the non-catastrophic model, we need to see certain things which have taken place in a chronological order. Number one, there was nebular hypothesis resulting into the formation of homogeneous Earth. Next thing, in the catastrophic model also, here it is specifying that yes, there was bombardment over Earth's surface, okay, resulting into the formation of continental nuclei. Okay, now in the initial part, the homogeneous Earth is formed, and the outer part, different density differentiation has taken place, and the outer crust of the Earth it was cooling. It resulted into the formation of oceanic crust. So here, first thing we see that we have the formation of oceanic crust, and second thing, there was formation of continental nuclei has also taken place. So these two things we can see here, they have formed here. When we look at the composition, the outer layer of the Earth, which was majorly oceanic crust, it consisted of basic to ultra basic magma. Okay, it consisted of basic to ultra basic magma, while the continental nuclei, which formed later on, it consisted of felsic magma. Okay, it majorly consisted of felsic magma. So this was propounded in this non-catastrophic model. Now, because of this, what we'll be seeing that over the Earth's crust, there was formation of continental nuclei. There was formation of continental nuclei at the different regions of Earth crust, which was surrounded by the oceanic crust. Now, this is the first phase. Now, when we move to the second phase, what we'll be seeing here, there was growth of continental nuclei through continental accretion. Now, when we look at this particular aspect here, we'll be seeing that when the continents are formed here, there was emplacement of magma has taken place from the interior of Earth. Okay, there was emplacement of magma. Here, what will happen after a certain period of time? The process of denudation will begin, and because of the process of denudation, there will be deposition of sediments will occur, which will be coming out from this emplaced magma. This is deposition of sediments. Okay, so here we'll be saying that this is one of the belt which is produced in the initial part. There was formation of initial belt has been formed here. Okay, so majorly this will be now looking like this because of denudation and erosion. So these were called as new greenstone belt. These are called as new greenstone belt here. Okay, so what happened next? You will be seeing that the continental nuclei, it started to have deposition of sediments around the continental nuclei. So this is one thing which we see here, which happened during the course of the development of continental part here. Now, after a certain point of time, okay, we'll be seeing here point number 4. After a certain period, because of deposition of sediment and isostatic adjustment, okay, because of the deposition of sediment and isostatic adjustment, here we see this is oceanic, we can say crust, and here we have continental crust. So here there was deposition of sediments in this part, but the oceanic crust with time it became thin, plus it became more dense. Okay, it became more dense. So because of this part, there was a subduction. The subduction of oceanic crust below continental crust. So because of this event, what occurred here? The continental nuclei, which were present in different regions, they started to move from their original place because of the subduction of oceans. Because of subduction of oceans, the new continental part, they started to move in different directions. Okay. So because of this, what we will see here that in the later phase, this resulted into the formation of cratons. So here we'll be seeing that there was formation of initial continents. The continents started to form from the continental nucleus. Later on, what we'll be seeing that in the next phase, there was still movement of these continents from one region to another region, which later resulted into the formation of what we call them as supercontinents. Example, Rodinia, almost 1.2 billion years ago from now, and Pangaea, almost around 250 million years ago from now. So this resulted into the next stage, which was called as the supercontinent cycle. So this was explained by this non-catastrophic model. Now, here we can understand that how the movement of this plate has taken place. Okay, and these were called as crust at those initial part, but now they are called as plates. So this resulted into the initiation of the cycle of plate tectonics. But there is another question which is still going on. The oceanic crust, which is majorly seen in the contemporary time, it is just 200 to 250 million years old. Okay, and there is no crust, almost no crust it is present, which is older than 250 million years ago. So here we see that there was ocean cycle, that the subduction of oceanic plate okay, this results into the destruction of ocean floor or plate, and it is also resulting into the formation of new oceanic plate at mid oceanic regions. Okay, so here we'll be seeing that this is mid oceanic region and this is this subduction. Okay, so here we can see the presence of trench. Okay, and here is mid oceanic region, Here we see that the new plate it is constructed, and here the old plate it is destructed. Therefore, this cycle it is resulting into the oceanic plate not older than 250 million years. Just give me a second. Okay, so here we can also understand the ocean crust or the ocean cycle, that why the oceanic plate they are not very old, while the continental plate here we can see they are found almost 4.0 billion years old, but the oceanic plate they are not found beyond 250 million years old part here. Okay, so this was one of the part which we can understand here, that how there was uh, the evolution of the oceanic crust and also the evolution of the continental crust. Now, in the next phase, what we will be seeing that there was formation of new oceans. So, for example, we have already understood, we have seen uh, in terms of Atlantic Ocean, Indian Ocean. Okay, here what we'll be seeing that first there was presence of Pangaea and the super ocean Anthalsa. Okay, almost around 250 million years ago. Then we'll be seeing here there was breaking up of Pangaea into Laurasia, and this is Gondwana land. And there was formation of a sea in between them, which was called as Tethys Sea. Okay, so this was Tethys Sea. Now, after this, what we will see that the Gondwana land, it also started to fragment with time. And the Angara land, it also started to get disassociated. And here we'll be seeing that there is still presence of Tethys Sea. Okay, there is still presence of Tethys Sea. Now, in the next part, we'll be seeing here that the South American plate, it moved ahead. The North American plate, it moved ahead. This is the European region. This is the African region. And the Indian plate, it was present here first. Then it collided with the Eurasian plate. And this resulted into the formation of Eurasia. And here there was formation of Indian Ocean. Here was formation of Atlantic Ocean. Okay, and here what we see that there is certain remnant of Tethys. It is present in the form of Mediterranean Sea. Okay, so this helps us to understand the opening of the or the formation of the new oceans. Okay, and the formation or the continuing of this cycle here. So through this catastrophic model, we are able to understand Through this catastrophic model, we are able to understand that how non-catastrophic model explained not only the formation of oceanic crust and continental crust as done by catastrophic model, but it also explained, number one, growth of continental nuclei, number two, process of denudation, number three, supercontinent cycle, number four, initiation of plate movement, number five, formation of new oceans, number six, closing of old oceans. So these are certain things which we see that which is explained by the non-catastrophic model, and which is one of the part which is overcoming the limitations of catastrophic model here. Okay, so this is an answer for this particular question. The answer is, the question seems to be quite simple, but the explanation to this question, it is not so simple. Okay, so Priti, Yogesh, have you understood this question, that how to approach for this question? Any doubts or queries, you can address it to me. So okay, got it. Yogesh got it. Okay, so what we will be doing here, today I will be stopping this session because 5:30 we have another session on a mentor case. Okay, so I will be discussing certain case studies of this June month. Okay, not of the previous month. Okay, not old case studies will be there. They will be the case studies which are coming in this particular month. Okay, from the various sources. So the link will be provided in the group. So do join the session and be ready with the next topic for day after tomorrow topic, that is the interior of earth, because we were not able to take any question from that part, the interior of earth. And you can also follow the details which is provided in the brochure. Okay, the session plan. So we will discuss questions accordingly. Okay, so guys, I have a question to ask, that how did you find this session? Is it useful? It is just repetition of topic, or it is just out of the box? Okay, Yogesh, your friend has referred to you. What is the name of your friend, Yogesh? Okay, Sarvana. Okay, I spoke to Sarvana, I think yesterday only. Okay, so that's nice. So, how did you find this session? Yogesh, are you there? Okay, I joined the Telegram channel. Okay, so how did you find this particular session? I'm asking that. The session was useful. You know everything already. How was the live answer writing? How was the evaluation? Useful. Okay. Okay, so go through the session plan, and day after tomorrow we'll be meeting again and we'll be writing answers. So our target will be to cover at least 5 questions in 2 or 2.5 hours. Okay. I just started my first answer writing today. चलो ये तो बहुत अच्छी बात है. This is a very useful thing because what will happen with this first? See what you did today. You took the first step. Okay, what we call it in Tamil, that is Nallapatti, right? So that is the first good step that you have taken today. So continue taking this step because it will make you self-reliant. It will make you, this session will make you quite very useful with respect to the mains answer writing. Okay. Simultaneously, you will be able to self-cover uh, your preparation for optional because you are self-preparing. And with that, you can complete the syllabus also by writing these answers. Okay. Okay. Welcome. Priti, you have any doubts, any question, queries to ask? Okay. So guys, I have one announcement because this is part of a paid program. Okay, as you might be knowing. So if you feel that this is a good program, you have to continue with it. This will be available for on. Okay, it is not an issue. You will be coming here, you will be writing answers, you will be getting feedback and everything. And this is a paid program, so I am there, my team is there. Okay, so there are a lot of people working with me simultaneously. So if you enroll in the program, if you take the admission, so it will be quite good for me also and my team also, because we also have, and they also have their family to support. Okay, so do go through the brochure, to go through the anything that you require. Okay, and in case of admission, you can speak to me directly. Okay, or else I'll give you the number. Okay, and in case of fees related queries, you can also speak to me. Okay, so friends, see you in the next session in around 5:30. Okay, we'll meet there again and we'll look at the mentor case. Okay, chalo, 20 minutes. We'll take a break of 20 minutes and we will meet again. Okay, this will be the same link which will be provided. You can join the session with the same link. Okay, chalo. Bye bye, guys.